Hey, geometry, here we are, and we are looking to use some right triangle trig. So we're going to do some right triangle trig. But then what are we going to do with that? It's kind of like a combo problem. So these are all about combinations. Pardon my kind of quick, scratchy writing there. We'll work our way through this and we'll be able to find some pretty easy patterns when we break them apart, because when they're put together they're definitely harder to work out. Alright, so let's go ahead and start with one of these here. I'm going to start with 74 because it's got an interesting pattern in it where you can almost kind of cheat your way through it because it's got some special relationships. So actually, no, let's come back to that one. Let's come back to that one. This one's a little bit special, you could say. We're going to do some of these other ones though, where we got to work our way through the calculations piece by piece. All right. So here's my first thing. Let's say I'm looking at 73. I am looking at 73. And then I'm asking myself, all right, it's asking me to find x and it's giving me junk over here on the, not junk, but other stuff over here on the other side. And then I start seeing like, well, is this like one triangle, two triangles, three triangles? It kind of looks like three. I kind of don't really know. I'm not really sure. So let's go ahead and do this. Let's make this so that, here we go. Let's give ourselves some blank things that we can fill in. So I'm going to cover up this down here so we can work below it just a little bit. So I'm going to make some shapes, here we go, that just break this apart. So I'm going to make one here. So here's like the left triangle, you could say. And then we got another triangle over on the right here, and I'm going to put it pretty much right next to it, because if you notice, like that vertical piece, that's kind of interesting for both of those. We're going to talk about that there in a second. So let's see the information that I do have. Well, for this one on the left, I know that this side is 19. I know that this is also a right angle. And in here, this is 68 degrees. Okay, so we got that much so far. And then over on the other one, I know that this right here is being called x, and this angle in there is 60 degrees. And this is a right angle. Now there's a couple other things, the interior of a triangle has 180 degrees, and in particular right triangles have this weird pattern, not weird, but just a pattern where the two acute angles are always complementary. They always add up to 90 because the right angle takes up half the 180. That's 90, that's 90. So then the other 180 is split up between the other two angles. So that's kind of interesting there. We also have been looking at this thing like so, and then ka, and then toa, and we got these combinations going on. I'm actually going to look at all of them and see which ones even help me. So let's do something else. Let's put some more letters in here. For example, like this is x. How about this piece that was on both triangles? Because I'm going to use that more than once. I'll call that y. It's on both of these, so I'm labeling it both times. So I'm going to label it up here as well. And then down these bottoms, I don't know, we need a couple more letters. How about w and z? So we got x, y, z, and w, y. There we go. All right, so how do we deal with this now? All right, so I have this triangle over on the right. We got 68 degrees. Let's say I were to do sine 68 degrees. Well, that's the opposite over the hypotenuse ratio. So opposite the 68 would be y, and hypotenuse would be 19. That's cool. That's something I could solve because it's just got one variable. Let's look at another one. We would have cosine 68 degrees would be the adjacent. That would equal w over 19. All right, that's pretty cool. So I could solve that one as well if I needed to. And then the last one, tangent of 68 equals y over w. Now that's not really useful to me because it's got two variables in it, and that's kind of the key to noticing I need to do something else first before I can do that one. So I'm going to kind of put that one on hold. We're not really going to mess with that one. The other two will give us y and w without trying to get us to do something extra. All right, now up here 60 is up in the top acute angle, so that means that z is the opposite. So if I were to do sine 60 for this one, that's going to be the opposite z over the hypotenuse x. Okay, now that's interesting because they're having me try to find x, but I'd have to find z first, and I don't know anything about this triangle as far as the sides go. All right, so then let's see what else we can look at. Cosine of 60 would be, let's see, that's going to be the adjacent over the hypotenuse, and the adjacent in this case is y over the x. There we go. And that's kind of interesting because y is involved in the other one, and it's got the x here. But still, I can't really solve it right now. Let's look at tangent. Tangent 60 gives me opposite, which would be z over the adjacent y. Okay, now that I have that information, what can I even do with that? Well, okay, not much. Yeah, I can't really do much here. The only ones that I could even attempt to start are this one and this one, the sine 68 and cosine 68, because I have at least a number there. So I got to somehow use this number. All right, so I'm going to erase all the other ones, or not all the other ones, but the ones that I know for sure are not really going to help me. So there's that one. Whoa, we got some of the background peeking in. Let's take that back. We'll just cover it up like this. There we go. And this one here, I don't know if we're going to need that. I don't know about these ones yet. So let's calculate these first. And then we'll see which one's more useful to us. So the first thing I notice is that if I were to solve each of these, I just got to multiply by this denominator. No problem there. Then I got 19 sine 68 equals y. Similarly, 19 cosine 68 equals w. Well, let's see what those things give me. I'm going to type them into my calculator. So, real simple Google calculator. I'm just going to type it right in here. This would give us, let's see, we got 19 times sine 68 degrees. Okay. Now I typed in degrees there, or you can use this Google calculator and just make sure it's on degrees. But that gives me about 17.6. So if I were to go back to that last piece there, I would see that this one times the sine, this was about 17.6. So y equals 17.6 in here. That's cool. Now here's what I'm noticing, because when I find w, I can't really use w over in the other triangle, but I can use y because it's like it's the connecting piece. It's in both of these. So over here, where there was a y, I can take this y out and say, well, that's 17.6. That's awesome, because then I could use that to find x. And in fact, let's go ahead and do that. I don't need the cosine 68. I don't need this one down here, and I don't need this one up here either, because these two are the ones that connected to each other that got me to x. All right, so let's see what would get me that. Well, I know that if I got a proportional relationship here, one fraction equals another fraction, you can multiply both sides by the reciprocal, and then what happens? Well, by both reciprocals, by each other's reciprocals, then you would get flipped versions. You kind of reciprocate both the pieces. So 1 over cosine 60 equals x over 17.6. All right, now our math is getting a little bit easier. 17.6. So that tells me that 17.6 divided by cosine 60 is going to be x. Well, let's see what that would become. So that's 17, we'll clear that, clear entry. 17.6 divided by cosine of 60. Now I don't have to put DEG here because I've already selected DEG on the calculator there. And that gives me 35.2. All right, so there you go. X equals 35.2. Now, what would I need to do here? I kind of need to confirm that that actually makes sense. It's not just some random number. It's not just something like, oh, look, I came up with a number. So 35.2, that's about double 19, a little less than double. And x definitely looks around double the size of 19 there. So that's a reasonable answer. So what was the key and what we were looking for? Let's kind of summarize what we did there. First, we set up some equations. Set up some equations. Then second, we were looking at, all right, how can I split it up? Well, no, let's start with step 0. Split it up into smaller problems. Split up. Split up the shape. Then set up some equations with the SOHCAHTOA combinations. And then the last thing is, solve what you can. Start with something. Start with 1, and then connect to the other triangle to find that specific piece, that desired piece, desired value. And what is the one that they're always asking for? X. Alright, so this is kind of just a quick video on this one. I'll do a follow-up with maybe some other similar ones, but we're going to start with this one. Try to keep it short. Go back and watch this one again before you get into the others. This is kind of like an introduction. The other ones might go a little faster.